Jet stream patterns during El Nino and La Nina events are directly the opposite. During El Nino seasons, we typically get an area of low pressure that develops over the eastern Pacific, and so that counterclockwise circulation allows the subtropical jet to be a little more active, and it branches off across the southern tier of the United States, resulting in generally cooler and wetter than normal conditions. Whereas La Nina is just the opposite. We have high pressure mounted over much of the Pacific there. Again, clockwise circulation. We've got sinking air. The jet stream builds into much of Canada and really keeps the cooler and wetter conditions at bay, mainly concentrated across the northern tier states into the Great Lakes region. So recent ENSO events going back for the last 4+ years. Again, you'll notice here back in 2010 we actually had a fairly strong El Nino that developed during that year. Again, we had much above normal precipitation that fall and winter associated with that El Nino. But again, you'll see here from 2010 and again in 2011, again we were below that ½ degree Celsius departure from normal threshold. So we had back-to-back La Ninas. We did tend to try to develop some El Nino conditions during the late summer into early fall of 2012. But the problem there, it was just conditions. It was not a bona fide episodes because conditions really dropped off very quickly and much to our surprise during that fall season. So it wasn't classified as an episode. But looking at the last weekly value, again, we've been hovering at nearly this ½ degree Celsius threshold really for portions of the summer. We really dropped off about midsummer, but again we've been right here or just above the 0.5 degree threshold really over the last month or two. So just conditions that are trying to develop. El Nino has been very stubborn to develop so far this year. In fact, if you look here at sea surface temperature anomalies, concentrate again on the right hand side, and we're seeing some of the anomalies slightly warmer than normal across this region. Again, this is the Nino 3.4 region that we're looking at here for El Nino and La Nina, and so near to slightly above normal temperatures so far through about the end of October across this region here. So how strong will the ENSO, El Nino or La Nina, be for this winter? Well, we've got a bunch of different dynamical and statistical models that we like to look at, and for the most part the majority of them are indicating very weak El Nino conditions developing later this fall and through the wintertime, early springtime months. If you kind of draw a mean of between all of these models here, again, very weak conditions expected late this fall and into the wintertime months. So, and it appears that this will begin to drop off into more neutral conditions perhaps as we make our way into later in the spring and especially the summertime months. Looking at the probabilistic forecast from these same models, again they're higher than normal, slightly higher than normal confidence that El Nino conditions will be developing later this fall and into the wintertime months. But again, something I've noticed is the fact that these probabilities have been dropping off over time. So we'll just see if this has to verify or not. So again, El Nino conditions are developing. They remain forecast to develop this fall and wintertime and through the spring. Please note that the Climate Prediction Center did issue an El Nino watch way back in early March of this year, indicating that conditions are favorable for El Nino conditions to develop during the next 6 months. They've just been very slow to develop. A couple of topics I do want to bring up that could influence the potential for El Nino later this season is first off, the Arctic Oscillation. This is just a review from our last presentation. This refers to the atmospheric circulation patterns in the northern latitudes in the near the Arctic region. Typically, if we have higher pressures develop over the polar regions, lower pressure develops over the mid-latitudes, results more in the jet stream patterns diving south. and resulting in much colder than normal temperatures east of the Rockies. Whereas the positive phase, we've got lower pressures over the poles, higher pressures over the mid-latitudes, so that keeps the colder air bottled up well north into parts of Canada. So one thing we'll have to pay attention to, if we get this negative phase of the AO that develops, then that will tend to amplify the colder temperatures over our region. The North Atlantic Oscillation, or the NAO, that's the same thing. Again, but it refers to the strength of the Icelandic low and the Azores high. If these features are fairly weak, then it allows, you have a negative phase of the NAO and allows the colder air to plunge south. Whereas the positive NAO, these low and high pressure systems are much stronger, and so it keeps the jet stream bottled up along the U.S. and Canadian border. The only problem with forecasting these phenomenon is the forecasts are only good about 7 to 10 days out, and then you start introducing much greater uncertainty across these regions here. So, but again, we won't really start to see the effects of these until, especially, we move into December, January, and February. So, but one thing I do want to bring up, and this is something that I did some research here locally based on neutral conditions or weak El Nino conditions developing through the November and February time period. I've went back in time, looked at records for this 4-month time period. There's only 7 instances that we had very weak El Nino conditions developing between, say, a ½ degree and less than a degree above normal with sea surface temperatures. But generally, you know, it indicates that slightly to much above or much below normal temperatures are found generally east of the Rockies, which is kind of typical with the strong Arctic oscillations. Whereas the precipitation, actually, we're looking at drier than normal precipitation across much of our region during these 7-year instances here. So I did some research, and again, I found in many of these years, with the exception of 1953 and 54, as well as 2004 and 2005, I found very strong AOs, Arctic oscillations, and North Atlantic oscillations during these other weak El Nino time periods here. So what it basically happened, we had cold front after cold front, which reinforced a lot colder air down across the eastern half of the countries, which essentially shut off the Gulf flow from the Gulf of Mexico here, so, and resulted in drier than normal conditions here. Truth behind the precipitation departures, again, for selected cities across this region. Again, I found a distinct dry bias across much of our region of North Louisiana, far southwest Arkansas, and East Texas, compared to the climatological average during that 4-month time period. So while the expectations are for cooler than normal and wetter than normal conditions, we might see something otherwise here across our region during the wintertime months. So the official forecast from the Climate Prediction Center, it does have, again, this is only probabilistic forecast. It's indicating higher probabilities for cooler than normal conditions later this fall and into the mid-winter months, with higher than normal probabilities for above normal rainfall. Again, the further south you go into Texas and Louisiana, the better the probabilities for seeing below normal temperatures and above normal rainfall or precipitation. The same could be said for the January through March time period across the southern tier of the United States here, with the temperatures and also with our precipitation as well. So again, I would take these forecasts with a grain of salt, especially given the weak El Nino conditions developing, which may not materialize. Fortunately, we're moving into our cool season. We're not really hit too terribly hard with drought now, and so the expectation is for the removal of the moderate drought conditions across areas of East Texas. This drought outlook only incorporates D1 or higher, so it does not incorporate the D0 or the abnormally dry conditions here. So they're expecting enough rainfall and cooler than normal temperatures for the D1 to be removed across areas of East Texas. That's all I've got here for you this morning. If you have any questions, feel free to shoot me an email. There's my email address. I'm going to go ahead and